Okay, so the first formula that we talked about was with respect to x, meaning perpendicular to the x-axis. So now when we talk about this volume formula here, we're talking about perpendicular to the y-axis. So perpendicular to the y-axis means you're going to have an x is equal to something, and this will be a dy problem. Okay, so they gave us the bounds of y is equal to c and y is equal to d, so this is going to be from bottom to top. Okay, and then you have the cross-sectional area is perpendicular to the y-axis, and this is your area formula. And then they give you the volume formula when it is with respect to y. So here we have the volume is equal to the integral from c to d, which is going to be our bottom to top, okay, our bounds. And then the area here, a of y, is going to be the right minus the left inside the area formula of whatever cross-section you're using. And then we have dy. So remember, this represents my height, this represents my width. Okay? All right, so these are all possible slices or cross-sections that can be used. Okay, so possible slices of a of x or a of y to build a solid by cross-section. So if it's a of x, that means perpendicular to x, which is going to be a dx problem, and this means perpendicular to y, and this would be a dy problem. So that means this has to be x is equal to, and this has to be y is equal to. So let's talk about a few of these cross-sections that we could have. So if we have a square, a semicircle, okay, so a square. This is a pretty basic and simple. If I were to ask you to find the area of a square, I'm hoping you would tell me if this is a side and this is a side. These are all equal. That's what makes it a square. The area is equal to side squared. So this side would basically be my top minus bottom or my right minus left, and I'll show you the application when we do an actual problem. But this is what you need to do. So you're putting the area, this is your cross section, so you're putting the either right minus left or top minus bottom into the area of the cross section, and then you're integrating that, which is what's going to give you your volume. But you have to be told what the cross section is. So for a semicircle, this is the portion that's put down as your side, as you would say, for example, just like our square. But typically when we find the area of a circle, we use pi r squared. However, this is our diameter. So the relationship of the radius and the diameter is that 2 times the radius is the diameter. So in order for us to make the substitution here for this radius, we need to solve this for r. So r is equal to 1/2 d. So what we have here, because this is a semicircle, the area is equal to pi over 2 r squared. So now we're going to make that substitution from here. Okay. So now we have the area is equal to pi over 2 times 1/2 d squared. So now the area is equal to pi over 8 d squared. So this is what you need to know for the semicircle. So this d in this case would either be my top minus bottom or my right minus my left. Equilateral triangles. Depending on how you find this, remember each one of these sides is exactly the same. So if this was S, this would be the same and this would be the same. If you're using 1/2 your base times your height, okay, what you end up with here is the area is equal to the square root of 3 over 4 side squared. One of the easier cross sections is also a rectangle. You have base times height. So the area is equal to the base times the height. But the most important thing is that you need to be given a relationship between base and the height, meaning you need to know that the base is, I don't know, 3 times as long as the height, or something like that, because you can't have two variables here. You have to make a substitution of one in terms of another. Okay, then we have a right isosceles triangle with the leg as the base, and then the other one with the hypotenuse as the base. So if you're looking at this shape right here, if I call this L and I call this L, this is a right angle here. Okay, we have this. So then if I were to use this, this is 1/2 the base times the height. So it's 1/2, this is my area formula, L times L. So your area formula is going to be 1/2 L squared. And you can label these anything you want, B, M, K, it doesn't really matter. I'm just indicating this as a leg. L is equal to your leg. Okay, leg in the base. Then if we have the right isosceles triangle with the hypotenuse as the base, this right here is my hypotenuse. Okay, that is my base. That is what's going to be sitting on my paper. So then if I drop a perpendicular down to create a right angle here, we know that just taking a look at this side, which would be my triangle, this is going to be 1/2 H, not your height, but 1/2 H. So then if we're using our base times our height, okay, your base is going to be 1/2 H, okay, here's your base, 1/2 H, and then your height is actually also going to be 1/2 H. And the reason why I say this is my base right here, so your area is going to be 1/2 your base, which is actually H, and then your height, to figure out what this is, if I'm taking this triangle, this is going to be 1/2 my height, and remember this is equal to this. So this right here is 1/2 your hypotenuse. That's what H stands for. Okay, so this is 1/2 the hypotenuse. So area is equal to 1/2 base times height. So that means the area is going to be 1/2 my base, which is the hypotenuse, times my height, which is 1/2 the hypotenuse. So the area is equal to 1/4 H squared. Okay, so then the last two that are on here, one is a trapezoid, which if you recall from going through the Riemann sum, we had the trapezoidal method, if you don't recall. Here, if I drop these down to create a right angle, this is going to be base 1 and base 2. It doesn't really matter which one you label, because the area for a trapezoid is 1/2 the height times the sum of your two bases. Okay, so this is important to know this. And that's your formula right there. And then any shape refers back to when you're finding the area between two curves. It just depends. If they say that the area that you're finding between the two curves is also going to be your cross section, it would be the area is equal to the area of the enclosed region. So then your side would be your top minus bottom or your right minus left, and this is what we covered in 6.1.